most of these injectors on the market today, it's a crapshoot what you're buying. You know, and I'm not trying to make this political, but China is making rip-off copies, counterfeits, of most of the stuff we have. We get injectors in here. They look exactly like a full-fledged Bosch injector, but it is a Chinese counterfeit. When you measure them, you'll see differences in them. People are buying those things. We've got a couple of videos on YouTube about it. And people are buying those things, and most of the time out of the box, the truck doesn't even run right. Or if it does run, it won't run for long. The material is inferior. They're shiny, they look good, they're cheap, a little over $100 a piece, but they're garbage. They're complete junk. They won't last you, I promise. Hello, thank you for joining us today. Today we'll be demonstrating the operation of this X420-SP, common rail injector tester. This thing is designed, it's pneumatic. It operates off of compressed shop air. Typically, it'll do 33,000 psi injection pressure to test virtually any common rail injector on the market. That'll fit in the machine. Obviously, it's got to be, you know, no bigger than, I think one of the longest ones is, you know, your LML and your 6.7 forward. So it just has to be able to physically fit inside the machine. And as far as the injector output, we can do up to like a 5.9 Cummins that's 100% oversized. So that would be probably 220, 230 millimeters cubed, about 150 or 160 milliliters per minute at 600 pulses is generally about the capability of the machine. Stock stuff are no issue. So this particular machine is for a John Deere dealer to do just a couple of Denso injectors only. It is essentially a stripped down version. They only wanted the capability to be able to test just a couple of injectors, so this one will not do piezos. This one also features a graduated cylinder. And we recommend a graduated cylinder like this for anyone that is first getting into this, and especially if they're going to be rebuilding injectors. They really need to be able to see that fuel going into that cylinder and be able to make adjustments based on that. It's not that the digital one won't offer those same type of capabilities and characteristics, but the digital version, which does all its measurement digitally, it's automated. You come through here and you do a test, it does them all. It doesn't stop, it carries on, it goes through and does every test, and at the end you get the final results. So with this one you can independently pick which test you want to run. Okay, so some questions we always get. Well, what makes an injector bad? You know, how do we know our injector is bad? Well, you'll start getting wear. You know, visible signs from the vehicle will be, you know, maybe you have to give it a shot of ether to get it started. You know, maybe it's just an extended crank time. You know, maybe there's white smoke at startup. You know, maybe you have a noticeable, you know, miss at idle, maybe like a lope. You know, maybe when, you know, you're going down the road and you're under heavy load, you jump off the throttle, it wants to continue to accelerate for a second. You know, maybe you're getting fuel in the oil. You know, things of that nature, you know, you may notice. And injectors, they could be the issue for any one of those complaints. So, predominantly, and we'll tell you exactly, you know, what each aspect of the test involves. So when we come in here and we start our test, so we're going to see, like up here, this is where we're going to start. That's going to be a leak test. So what's going to happen here is we're looking for, you know, a visual sign of a leak from the injector body, you know, from the solenoid up here, potentially. These LB7s, they're bad for the inlet fitting leaking here. This is threaded into the body of the injector. You know, we've seen leaks, you know, cracks in all different places. We've seen when you know, people put those rail plugs in, it'll actually expand this nut from high pressure, and you'll have leakage, you know, from around here, and I've seen it run out of the valve cover diesel fuel before, or it ends up in the combustion chamber, you know, one or two places there. Or you can have a crack in the nozzle, or you can have wire from the nozzle, and they'll start dripping under pressure, you know, without the injector even being on. So when you go to test one and it's like that, you got a leaky nozzle, you know, you'll have on your output what's coming out of the nozzle. The return is what comes out of the body. On your output, a lot of times these results will be inflated. You know, your numbers will be high because you've got a leaky injector nozzle. So the first test we're going to run is going to be what's called an LK test. We'll go ahead and start this thing up and run it for just a minute here, kind of show you what's going on. You see, we're building pressure here. We're going to go to 160 MPa. And we see no visible leaks. And you can look at your return. Ours is about 16 or so. We're good there. Alright, so you can run this as long as you want to. Another, we've got an aspect here. If you want to drop the pressure, you hit this pulse button. That shows you the injector is functioning. So now you know the injector's working. There's no leaks. You know, there's no issues from anything there. And obviously, you would want to take this collector off and run your leak test with this removed. This is a brand new injector. We know it's not leaking. So by having this removed and running it, you're going to see if anything's coming out of the nozzle to know if you got an issue there. So if everything passes, then you're going to come down here and you're going to run these output tests. Now this one is 101 MPa. So we'll run this one for just a minute. We're getting flow into the graduated cylinder now. So we would run that test to its completion, and obviously we would start with an empty cylinder. So what you'd want to do when you start doing this test, you pick your test, you'd start it just like we did. Go ahead. You'd want to fill this up, this tube here. So if we were going to go back and run this test again, or actually for the first time to measure the output, we're going to dump this. We're going to put it back in place. Then you would start your test. Alright, so what you've done, you filled your hose up. So now whatever's going in the cylinder, if you run this test at 600 pulses for the full duration, your results should be within this range, 59.8 to 65.2. And while you're doing this, you'd be monitoring the return. So if we get results that are higher, wherever the first return is over limit, and it's probably going to be in this test here, you know, as we're testing the nozzle output too. If it's over limit, you're not going to go any further. You've got injector problems that are going to have to be dealt with. So some of the reasons you may find one being over limit there is due to wear. These parts, let's see if I've got a valve assembly here. I should have something. So this is one of the top places where your return rate's going to be too high. This fit this control rod up into this valve here, 1/10 of a thousandths, 50 millionths of an inch. So once this thing starts getting scratches on it and gets wear in it, your return will start going up. Secondary place in here, there's a little tiny ball, 1.34 millimeters in diameter, that sets in here. And once you start getting some wear from fuel or debris or anything else, it'll start scratching up. It's like a cone. The ball sets in the center of the cone, sealing this passage off. When that happens, your return starts going up. So, there's different reasons, different things that wear. The fit of the nozzle, same deal, really tight. Down here in the bottom, it's the first place actually fuel is available as it comes in the inlet. It pressurizes the nozzle. You'll get wear in there, and the return rate will be too high. So what you do, you go through and you run all these tests. You would compare your results with the specifications, and you may find that you're in line everywhere but one test. That's why it's important to calibrate these things. When they're tested at different pulse widths, different amounts of on time to get the nozzle flow, and different pressures. And this represents everything from cranking the engine and starting it up to running at wide open throttle. So anywhere within that range, from cranking the engine to wide open throttle, you could, be witness to a problem you have, in one of those areas with your injectors. So that's why we test at such a range, because you may have a characteristic that, my truck starts up, idles rough, and white smokes. Or my truck at wide open throttle won't make rail pressure. It won't hold rail pressure. Once it starts getting hot, the rail pressure starts dropping. We get those questions all the time. The first thing people want to do, they want to say, I got a bad pump. Or my relief valve is leaking off. We got all kinds of questions. At least once a week, somebody, I want to buy a relief valve because I got a low rail pressure code on an LBZ Duramax. We hear it all the time. And I always point people towards their injectors because, that's just a simple fact. Well, my truck's only got 170,000 miles on it. I've had them in here with 5,000 miles worn completely out. Mileage is not an indicator of anything. We've had injectors in here before. We did some 305 horse Cummins ones out of a 2003 model. They had like 240,000 miles on them, and the guy had one bad injector. That old. We're talking 17 years old, going on 18 years old by the model years that we have now. And he had one bad injector, but I said, I can't tell you how long they were going to last. I recommend you rebuild them all. And he did. So, like I said, mileage is never an indicator, but typically, if you got drivability issues with a common rail, it's injectors. Now, it could be something else, but 9 out of 10 times, it's going to be injector-related issues. This is why we're putting a lot of effort into these machines. This is going to be probably the machine that we try to keep in stock all the time that we have the most of. Because it's affordable, and shops can use something like this. And a secondary consideration too, most of these injectors on the market today, it's a crapshoot what you're buying. And I'm not trying to make this political, but China is making rip-off copies, counterfeits, of most of the stuff we have. We get injectors in here. They look exactly like a full-fledged Bosch injector, but it is a Chinese counterfeit. When you measure them, you'll see differences in them. People are buying those things. We've got a couple of videos on YouTube about it. And people are buying those things, and most of the time out of the box, the truck doesn't even run right. Or if it does run, it won't run for long. The material is inferior. They're shiny, they look good, they're cheap, a little over $100 a piece, but they're garbage. They're complete junk. They won't last you, I promise. And they come in a box that says Bosch. We've gotten some of those parts, fuel control actuators. You get them for like $25 a piece. You may get one that works, you may get one that doesn't. It's hit or miss. Same way with all this Chinese stuff. So you want quality, you got to have people you can trust. And we've got some shops that we have worked with, and I'm telling you, you can trust some of those guys. But if you don't know them and they're just trying to make a sale, you better be careful of it. I would much rather, this way you know what you're getting, I would much rather rebuild my existing injectors that came out of my truck than buy something, even if it's new, because I'm really wary of what I'm getting these days. But, we have the capability to do this anyway. So, some of the things to consider when you're looking at a machine, are you going to be able to get service? Are you going to be able to get parts? Is it designed, from a simplistic perspective? Is it is it going to do what you need it to do to where you can understand how an injector works based upon what flow you're seeing? So that's our mindset behind this machine. That's our mindset behind our software. So once you would go through and you would complete these tests, and we're just going to put some bogus values in here. We're going to say the return was, number lock. We're going to say the return was 30. We're going to say the output was 58. Say that one was 20. That one was 15. Let's say that one was 80. 22. 16. 8. 7. 9. And we're going to say we were 17 on that. So this will be your results here. Let's see, I didn't put a number in there. We'll put 22. So we've got all these filled out. So when we're testing an injector, this is going to be the active injector number. Let's say there's 6 in this set we're testing. So this is injector 1. We've got him numbered. There's 6 in this set. So we're going to go and we're going to view our test results. Okay, we see them here for the different tests. And it also, it's not going to give us a variance here because we don't have other numbers. But it's going to give us a variance, which is really important, between all the different injectors we're testing. So we can see our spread percentage. You know, another consideration, you know, over the years, like extrude hone nozzles for, you know, increased output, you know, or EDM nozzles, things of that nature, they don't all flow the same, I promise you. Now, they've definitely gotten better. The market has made it in such a way that if you sell junk, you're not going to stay in business. So there's companies out there that have gone to, you know, like 1 to 2% on the flow variation, you know, between injector nozzles. Well, if you just buy a set of those nozzles and you put them on your injectors, you still need to calibrate them because you don't know exactly, you know, what that injector is putting out. So it's important that you see this variance here, because if you're doing that and you're putting a set of injector nozzles on, you want to get them within 1% or less of each other. 2%, maybe. But 1% or less, plus or minus 1, very good. So you're going to see this variance here. And we'll go back and we'll put, you know, maybe some numbers in for number 2. And if you come down here, you're also going to see this bar chart, you know, that shows you the output. And before you actually save the results, if you hover over it, you can see what that value was that we put in there. Okay, so then we're gonna close this, and we're gonna go back here and we're gonna put injector 2. All right, that cleared our results. So we're gonna say that this one was 59, 30, 22, 21. I'm just throwing random numbers in here that are between the ranges. We're going to say that was 82, 22, 15, 6. Let's say that was 3, and 4, and 20. Okay, so then we're going to view this. All right. So now we're getting a percentage spread here. Okay, so we've put numbers in here representing the flow at this one test for our entire, you know, set of injectors. And this one we have 6 picked. So our flow range being from 58 to 60 gives us a 0.82% variance. So, and obviously if we go back and we change one, I didn't save the results. Okay, let's make this one be crazy high, 68. We're going to go back and view. Now we see a variance spread of 3.5%. And we see them like that. I've seen them 11% before. That's 3.5. So once you get all these numbers in here, but let's say you're going to test, you know, you're just going to test one injector. Obviously there's going to be no variance there. But let's say that your injector count is going to be, it's going to ask you, do you want to increase or decrease the count of injectors, yes. Every time you go to do this, it'll give you a warning. Let's say it's a 4-cylinder. So you're going to test 4 injectors. So we'll go back and we'll view. We still have this 3.96% variance. So your chart's going to get a little bit smaller. So you see injector 1, 2, 3, and 4. Up here, you'll put your customer's name. John Doe. Technician is me. You've got your date here. And according to your test plan, it's going to put which injector you've tested up here. So, and then once you're done, you'll click Save. And it takes a picture of it. And then you get to come back here and you get to view it. And you can move it around. You can scroll in. You can scroll out. You can reset it. Scroll in on any individual aspect you want to look at. You can reset it. So we do this white so you don't burn up a lot of ink if you want to print these out. So you got a white background. So then you'll have all your results in here. And it puts them all together in one result page, which is awesome. So we can look, and like here where we have our 4% variance, right here, 3.96%, you'll see it on the chart right here. 1, 2, 3, 4. And you'll be like, oh, I see. Injector number 4 at 68 is really high. So anyway, there we have it. You'll close it again, and we'll close this, and we come back to our testing. Okay, so over here you're going to have recents, like as in recently used, and if you click to do a new injector, it's going to say, are you sure you want to clear all test results? Because if you hadn't saved them and you go to a different injector test and you click continue, your results are gone unless you save them. So at this time you would determine how many injectors I'm testing. I'm testing 1, 2, 8, ever how many. Your active injector, and then you would switch to the next available injector in the series. It only goes as high as the injector count here, which is 4. So we'd go back to 1. Another thing you can do here too, if you want to do a shorter test, all right, look at these results. You see, we're going to click this one. 49.6 to 60.4 should be your output. Okay, and let's say instead of running it for 600, we're going to run it for 300. Ta-da! It automatically reconfigures what you should be seeing at 300 pulses. That's how many times it's going to open the nozzle and fuel is going to flow out of it. So whatever you change this number to, and once an injector is fully warmed up, fully operating up to temperature, like, let's go back to this one here. So by the time we would do this leak test, if we run it for 3 minutes, and then we run this first flow test, which deals with output and return, if we run both of those tests, this injector is going to be completely warmed up. So we could come back for these other tests. Let me say this, the greater quantity you're putting in the cylinder, the greater that volume is, the easier it is to see deviations from injector to injector. But you could reduce it. You could bring it down here to 300 or 100 or whatever you want to do. Like I said, the more you can put in the cylinder to measure, the better off you're going to be. So I don't really believe in taking shortcuts, but there may be a time that, for some purpose that you want to, change the pulse count. Okay, another thing that we've got the capability of doing here, we're going to go ahead and start this again and run it for just a second at this test here. And we're going to stop it. And we showed you the pulse. You want to get the pressure to come down. All right, we've got something else here we can do, which is called a pattern test. Now I don't have we've got a plastic, it's a centrifuge tube that we stick on the bottom of the injector, and it'll etch the actual spray pattern of the injector nozzle onto here. Let me see if I've got one here loose. Not sure if I do or not. No, we don't. I don't think I've got one that's already made up. But anyway, I'm going to run that pattern test and show you what it'll do. So we're going to click it. You see, once it gets to, I think we got it set at 160 MPa. Once it gets to 160 MPa, it'll trigger the nozzle, and it'll etch the pattern on those centrifuge tubes that we have. Do it again here, and that's all it does. That's the test. Let's see if I have those tubes. We can show you what they look like. This is what we use. It's just it's a centrifuge tube. You can get 1,000 of them for probably 20 bucks or something. But it's got a cap. Designs you can do that with. But the size that the shoulder is the exact size, once you drill it, put it in there, of a 7mm diameter injector nozzle. So I'm not going to tell you what size drill bit we used to drill that, but I can't remember. So when you do this, you just you stick it over the tube, and it'll put the pattern, hole size and all, right on the inside of this tube. I think we've showed that in some other videos as well. So that's another neat aspect of the test. You know, if you get a nozzle that's got, you know, you see the flow is way off here. I've had them come in before and somebody's dropped them and, you know, they've messed one of the holes up. Well, you'll see it here, the flow will be off. So it's, in that case, you can etch the pattern on there and you can look at it and you can say, oh yeah, that hole's barely flowing anything at all. Or sometimes injectors that have been extrude honed, you'll end up with one huge hole and all the rest of them are the same size. And you'll see it on here. You know, you'll notice it. Plus you can look at the angle of the spray pattern and other aspects. So this pretty much concludes the machine, its capabilities. And we thank you for watching.